Hello everyone and welcome in this tutorial about audio reactivity. It's my first one. Many of you asked me for this one, and yeah, I released this tool 1 month ago but didn't have time to record this tutorial because I wanted to do it correctly. So yeah, I released this talks called ARE for Audio Reactive Engine. And it allows you to do a lot of different things about drums detection, the global dynamics of the sound, reduce FFT and image dynamics. You can download it here. The link will be in this video description. So yeah, once it's downloaded, you can find it on your computer folder and drag and drop it here in TouchDesigner. Okay, so we will explain the different parameter pages, starting from audio and tools. So here we can first set up the audio input. So the same way you do it here, you can output, for me it's this one. And if I do this, I will switch up to the, it's the same sample music that we have when we do audio file in. Yeah, it's the same music. So when you do this, select the output and audio file off, you should hear the music. It should work. If it doesn't, make sure that here you are on the same on the good output. Anyway, and you can switch to device. So in this case, it allows you to maybe you have, I don't know, an electric guitar and you want to put the sound inside of a TouchDesigner. So you may have a sound card for this, and yeah, you can select. For me, it's mic line 1 2 audio Evo 4. It's the input I will use if I want to record what's coming from my audio card. There is also the option to stream directly the music from Spotify or maybe YouTube inside of TouchDesigner. In order to do this, I will make a whole video about this because it's a bit tricky to use first. But I encourage you to download this software called VB Cable. So yeah, it creates like virtual interface, a virtual cable inside of Windows. And if I want to stream my music inside of TouchDesigner, in Windows, I will select VB Audio virtual cable output, so speakers, haut-parleur is speakers in English. And inside of TouchDesigner, I will say cable output. So now when I play music, okay, I hear the music. We go to LMH so you can visualize it. You can see that the music is playing and I hear it in my speakers. I hope that you don't hear the music in my speakers when I speak, because I don't have headphones. So yeah, I try to filter my voice and different things in OBS, but it's not perfect. I have to buy headphones. Anyway, so now we set up the audio. There is this graph section here where you can select or automatically. It means that when I switch page, you can see that here it changes as well. Okay, or you can set up manually. So here we are in section drums. We can go to global dynamic, reduce FFT, LMH dynamics. Okay, let's go directly into drums. Okay, so here we're gonna select manual. So we stay in the drums visualization, even if we change the page. And when you go to drums, you can see that there is a lot of different parameters. It can seem a bit scary, but it's okay because, for example, the drums, low drums output, the low drums parameters work the same way as the mid drums output and the high drums output. All these parameters work the same way. So once we understand the low drums, you will understand everything. So in this tutorial, I'm only gonna focus on the low drums because it will allow you to understand how mid and high works. And because I want this tutorial to be shorter than my other tutorials, and I want to make like different short tutorials for this. And I want you to play quickly with this tool. So let's put some music. Okay, so I forget to say something, that we have an input here, and it allows you to connect a sound. And if you do it, it will overwrite, bypass what you selected in this area. So this input is bypassing it. So you can not use these parameters at all, and just use your own audio in, right? Okay, so we have music now, but nothing is happening. We have here low, mid, drums low, drums mid, drums high. Sorry, my English is a bit fucked today because I only slept 3 hours the last night. Anyway, so we have music, but nothing is happening. It's because by default, you can see that the output are turned off. Why? Because this audio-reactive engine is also made to be used for VJing, and VJing means optimization. Optimization is mandatory for VJing. So if we click on the middle button of your mouse, you can see that the operators inside of this container need the CPU to cook during 0.1 or 0.2 milliseconds. And if we turn these on, you can see that it's increasing to 0.8. It's still okay, honestly. And the other parameters are way lighter, let's say. Anyway, we're gonna focus only on low drums output, so you can switch off this one and this one, and turn on the low drums output. We can see here that we have 3 different rows. So this row here is showing what's happening in this section, this low drums processing. The second row is for the mid, and the last row is for the high processing. So we're gonna read it from left to right because this is what's coming from the input, and this is what we output. So we have here this first graph showing the signal filtered by a filter. Yoo-hoo. No, really. So in this area here, we are filtering the signal, so we only keep the low frequencies of the signal. You can edit the cutting value by switching on this parameter, and you can see that when it's switched on, you can see that these parameters are now editable. Why there is this switch controlling the parameters edit is because if during, like, I don't know, DJ set or anything, it's turned on every time and you do this, there is no more signal, or I mean, it's fucked. So this is kind of security, you know? So you can change what is entering this section here, but I like to use 70 otherwise it will detect, I don't know, some snares or some hats in the music. So yeah, okay. So this dynamic here will be now transmitted to this step, this processing step. You can see that we have the kick bass trigger yellow parameter and the signal, the filtered signal coming from here. So this step here is saying that everything that it's gonna be, all the signal that is above this yellow trigger, it's gonna be transmitted to this step. So if I don't know, you can see that I can manage this value with this parameter. Because at this moment of the music, there is no kick. So it detects wrong dynamics. So if we do this, you can see that the signal is now under this line and won't be transmitted here. But now, yes, you can see that directly it sends the signal here when it's above this section. But if it's too high, you can completely lose the signal and nothing will be transmitted. So I like to put it to 0 when there is the kick, and when there is no kick, just turn off. So nothing is output anymore. But you can also increase this manually when there is no kick in the music. So yeah, this is the way signal is transmitted here. It's kind of deleting the background noise, but also can be used to bypass everything or to select just some music are very complex to analyze. So if there is a lot of bass, lot of kicks, you can just select the one you want at the very top, like this, you know? Anyway, the music we are listening to is very clean, the mix is very good, so, and there is not a lot of different instruments. Sorry, my English is fucked. I only slept 3 hours the last night, so sorry if my words are blah 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 blah, kind of a soup, you know? So yeah, I like to put this one at 0. Let's now focus on this one. This one here works kind of the same way, but we have two different triggers, the automatic one and the manual one. By default, the automatic is sending the data to the last output. So everything that is above this line, automatic line here, will be here a 0 to 1 value. So it's normalized. You can see that we have variations. Yeah, sometimes it changes automatically. It's why it's called auto. What does that mean? It means that it takes the higher value of the signal and then say, okay, I want the higher value. My trigger will be the higher value multiplied by this value here, this parameter, automatic factor here. So if this automatic factor, because it's a factor, will be between 0 and 1, you have no interest to be under 0 or above 1, and even 1 is not very interesting. Because 1 will say that it takes the maximum value and everything that is under will not be transmitted, so no interest to do this. And if we select 0, I mean, you have all the variations here are transmitted as a 0 to 1 output here. So 0.5 is often a good value, but you can change it. If it's not good, you can say, okay, I prefer maybe for this one, if we want to be precise, you can say this one. Okay, it works. Oh no, you see? Here we have an output and we don't want it. Anyway, 0.5 is good. But if the automatic is doing shit, you can also say, I want to trigger things manually. So automatic is showing here the value it calculates, 4.7. And here now is the manual one. Manual trigger that is saying, okay, everything that is above this manual trigger will be a 0 to 1 final output value. And the same way, if it's too high, nothing is outputted anymore. Nothing is output, but we can also, and there is no calculations again. This is completely fixed, so if the music stops, it stays at the same, you know, it stays at the same value, but automatically tried to catch the peaks and the dynamics of the sound. Okay, so I usually always work in automatic mode. Let's put another music. And yeah, it outputs the 0 to 1 value representing the kick. But all of these parameters work the same way for mid and high. It's exactly the same thing. Okay, so the kick is generally very precise. The snare can be very difficult to catch, especially in this weird song. You know this instrument doing because there is energy in this instrument. The system, the analysis understand that it's a snare because it's in mid frequencies and there is a lot of energy. But now you can see that the snare is tack, tack. It works perfectly. And yeah, same shit for the high drums. Let's find maybe a trap music to illustrate it. Okay, it's not trap. Okay, you can see here that it works the same way for the hats. You can set up everything the same way, so what's going on here. But I like to put it in 0, and here only play with the automatic factor. Okay, cool. So yeah, it works the same way. And okay, there is also this burst frequency parameter. So it's the fourth here called burst, and it's good during bridging. I will explain it in the next video, but you can burst 15 Hz 0 to 1 signal. If you connect it to a trail to observe it, no? Or you can press it with this pulse button, or you can just switching on, switch it off, and maybe just change the frequency. Okay, so I will explain the utility for this later. So yeah, now we gonna see how we can adapt these output parameters to a visual. Oh, okay, first, let's focus on the low. Let's change the music. I don't like this. Okay, I have very weird songs here, so don't analyze my. Okay? Yeah. Okay, it's good because it's good because it's binary music. Tac, 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 tac. We can now see that there is analysis type, or manual, or BPM matching. Why BPM matching? Because here we have this BPM detection, and it works like this. So you first have to press the first beat on reset, and then all the other will be on this one. So pop, 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 pop. Okay, so if you want it to be more precise, just be 2 times slower. Okay, this way. Because if it's slower, it means that it has more samples to analyze and then it's more precise anyway. Okay, sorry, I had to cut for a short moment. So it allows you to set up the analysis because this automatic value here is calculating during this this graph. You can also, by selecting manual, shorten the duration. So you can see that it's oscillating a lot. It's not really interesting. It's doing it's working here, but generally I don't like to use it because when there is no peak, it's just doing shit. So I like to use the 4 value, but you can also use the BPM matching. So here we have 1. So it means that we have always 2 kicks, 2 beats per graph. Here we have 4. We have always 4. So it can be like there is different type of analysis, but I like to use manual generally. And if you are, maybe we switch the music, the DJ switches very quickly, and the dynamics of the bass, of the kick bass is very different. You can also reset the analysis. So it will calculate immediately the new values of the signal, right? Like this. It's very useful. Anyway, now I'm gonna show you how to use this drum slow into a visual. I will use the visual I made thanks to my previous tutorial. But if you don't have time to do it, you can adapt the technique. It's not about doing exactly, I don't want you to do exactly the same things as me. I want you to understand the approach. I want you to understand how we can use this data to manage, I don't know, the scale of my particles, you know? So I will adapt it to my previous tutorial so I can send you, post this tutorial quickly. Okay, this sound here was not a fart. I didn't fart during my video record. It was my chair. So please don't tell me that I farted. I didn't fart. Thank you. But I really encourage you to explore by yourself and not just do the same things as I do. Okay, I cut. Now let's switch to the particles project. Okay, so why is it disconnected? Okay, so once we are in this project, we will import the ARE. Where is it? It's here. Okay. In the palette, you can go into My Components, add a new folder, and drag and drop it here. So every time you open TouchDesigner again, you can just do this. You know, it's very convenient. Anyway, I don't want to see the background, sorry, I'll just split my screen in two. Here, select top viewer, reduce the size, here, play backdrop tops, and I'm gonna change the resolution to 1080 1920. But it doesn't change because the feedback here is keeping the previous resolution. So in over here, I'll do this. Okay, so now I will show you the pattern. The pattern is the way I create, I manage the data from outputting from here for every audio-reactive project. So here there is this tutorial working with pops, but if you don't have access to pop, if you didn't follow this tutorial, you can do whatever you want. It can, what I will show you will adapt to everything. I will just put the camera closer to the geometry. Cool. Anyway, I'm gonna output a null like this on the drums low, so the first output. Here I will set up the sound coming from Windows again. At the moment this tutorial will be posted, you can find in description a link referring to another tutorial that explains how to bring the audio from Windows, so I don't know, Spotify, YouTube, Discord, inside of TouchDesigner. So cable output, and output is my main output. Here I have VB audio virtual cable, perfect. So if I go here and play and switch it on, okay, it works. I'm not gonna use the music now. Let's keep it on because I want to focus. And my chair is making so much noise, I'm sorry for this. Okay, so now we're gonna create the pattern. The pattern is put a select sharp. We're gonna select the output, bring it here. We're gonna create a constant called G lag for global lag, and default value will be 0.2. I set up the few nodes and then I will explain to you. So after this select, I add a lag, I add a math, and I add a null. Again, you can copy, paste, and here between the math and the null, add a speed. This is how everything works. So also select the two lags here and affect this constant value to the lags. So now all the lags are controlled by this value. Okay. So what's happening here? I'm gonna create something called annotate, so we understand what's happening. Let's call it pattern. So let's put on the music. We're gonna use the trail chop to understand what's happening here. So in the first node, we have exactly the output that we can see here. It's exactly the same. It's exactly the same. Then there is a lag to smooth the values. The problem with this is that the signal originally going from 0 to 1 now goes from 0 to maybe 4, 45, I don't know. And it's because of the lag. If we reduce the lag, it's gonna go higher. If it's 0, it will be exactly the same. And it's 1, we have smaller values, okay? So this is something you have to keep in mind. After this, there is this math. This math will allow you to adapt the 0 to 1 or 0 to 0.4 values to these parameters. For example, in the noise here, I have this amplitude going from 0.3, and I want it to, when the kick hits, to go from 0.3 to maybe 0.9, sorry. I don't know, like this. Bam, bam, bam. Okay? So initially the value is 0.03. And we're gonna say here in the range, okay, I want to go from 0.03 to 0.009. Okay? Let's delete this. Every time I want now, because I have this pattern, every time I want to animate a new parameter here, I will copy this. Copy, paste, and rename the null. So it's noise amplitude. I know it's boring to rename operators, but if you don't, and you have 50 operators, and you're like, okay, I don't like how the light is managed by my kick, I want to modify it, and there is hundreds of these gray references everywhere, I promise you to have the name here is very convenient. So, noise amp. We have this noise here going, it's 0.003. So, in this math here, range, let's write 0.003, 0.003. So now, even if we have the kick, it's always staying at 0.003. I will connect this value here to this noise amplitude. If sometimes the nodes you want to reference are a bit far, in this case it's okay, but if I want to reference this one to this one, it's boring. It's boring to just do this and try to take this. It's boring. So what we can do is right click here, view, and go here and select this like this. Okay, so what you can also do, I mean, it's whatever, how you want. You can rename it. It's not drum slow, it's, I don't know, noise amp. But I never do it. It's up to you. So we have now this value affected to the noise amp. Okay? So let's go to a moment where there is a kick. Let's increase slightly this value and observe what's happening here. See, it's good. But if we reduce the lag, it will go higher. It will be more powerful. Because more faster. We get close to 0. And if we go to here, you know? So let's stay at 0.2. Cool. Everything is working like this. Let's do it again so you understand. You don't have to go back to see how I did with the noise. Let's say that we want the scale of the box to get bigger when the kick hits. We're gonna add some space. But just after this lookup texture, managing the point scale, we're gonna add a math, viewer not active, and here select point scale. Okay. So now if we modify this value, if you multiply it, we can increase the global scale of the particles. So let's do it. Again, take this one, copy, paste, and rename the last thing. The last null, point scale. Okay, cool. So initially the value is 1. So step by step, the value is 1, so I add 1 here, 1 here. I take this value and I affect it to it. Like this. Now you can press play. nothing is happening, but now if we increase this value, I mean, it's up to you. I'm not here to show you the most beautiful things, but you can, it's for you to understand. So, different step. You search for the parameter you want to animate. You check its value, it was 1. You go here, you say to range 1 and 1. You affect the parameter, you reference this parameter to this one. No, sorry, to this one, and then you slightly increase the this maximum value. Let's do it again, but this time I want the camera to zoom in every time the kick hit. So again, select this, place it here. Let's call it camera cam Z, translate Z, the cam TRZ. So the camera value default is 3, so 3. Display this one, go to the camera. In this case, this thing is useful. You see, it's way easier to do the things. You can close it once it's referenced. And now we have the camera zooming in, but you can also zoom out. Let's change the music. I don't like to hear the same every time. Tac, 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 tac. Okay.
What you search for.
Okay, I wanted to zoom in.
But it's about what is missing. How do you improve? How do you progress? Are you searching?
The little camera zooming in creates dynamics.
How it grows progressively.
And also I created this one, this pattern here, but this time we have a speed. Because for the noise, we often animate the noise in transfer page here. It allows to because it's keeping the same shape here. But if we do this, changes. Let's stop the music. So here we have the same shape. But if we do this, shape is moving, right? Okay, so I want to manage this parameter. A lot of people are using this. I don't like to use it because now, how do I animate this with this? Okay, I can say that it's apps time point seconds multiplied by something like this. Okay, but I don't like this way of doing things. So you're gonna use the speed. It's way better to use the speed like this. So we're gonna select this one with the speed, put it here, and call it noise TR 4D because it's the translation 4D of the noise. So the value we have here is 0.1. So in the math, we're gonna say both are at 0.1. So if we connect this to this, it has the exactly same behavior. We can delete this. Don't forget to save your project. And when there is music now, we're gonna increase this, and you'll see that the animation between it will be happening at the same time of the amplitude increasing. Ah yeah, I like it. Let's change the colors a bit. It's cool, right? So this is low audio-reactive. No. Okay. Low audio-reactive parameters. But we can do the same thing, but for the hi-hats. We can hear here. Drums high. Enable it here. And in the same way, select this one, put it here, but instead of selecting drums low, let's select drums high. Cool. So this will be called high audio-reactive parameters. And let's say that we want the high is the hi-hats, the hats, or whatever drum, control the glitters. So let's call it glitters. And the glitters are managed by this phone here. Yeah, we can go to, let's reduce a bit this. So we're going from 3 to 70, 3 to 70. So first we have 3. Right click here, view, in the phone, reference it, and we set 70.
Are you searching?
But it's not very obvious because the lag is pretty high, and the hi-hats are fast compared to the tempo. So maybe we can reduce this to have more. But we can also do it on mid, drums mid. We have a problem here because the name initially was drums high and now it's drum mid. So here it says I don't like it, I want drums high. So let's reference it again. And let's enable this. You see? Beautiful now. And now you can manage all your parameters here. The parameters you want to play with are these. And the global lag. If the music is faster, you should a bit, in my opinion, decrease this value, and if the music is slower, you should increase it. But yeah, it's pretty, I love it. Okay, that's it. And this way of doing audio reactivity can be adapted to, again, every kind of operators. It can be subs, it can be pops, materials, as we see. It can be tops, it can be controlling other shops. Everything can be audio reactive thanks to this way of managing the 0 to 1 output we had first. So this was the first tutorial. I think it's already long. I expect it to be around 30 minutes, but I think we're close to 1 hour now. Yes, sorry, but if you want to understand everything, I prefer to make longer tutorials. Anyway, that's it. If you have better approach or techniques of analyzing and affecting parameters to the visual, please tell me, of course. And please, if you use this tutorial or use this beautiful component here, don't hesitate to mention me your social networks like Instagram, TikToks. It's not only for as a reward for me, it's also because I like to see new projects made with tools I developed. Really, I'm so happy to see I smile like a stupid boy every time I see artistic project made with things I developed. Anyway, I stop this tutorial here. All the resources are in description, and please take care and see you soon for other tutorials. I will try to record a lot of tutorials on audio reactivity. Anyway, bye, bisous.